Hello, in this video we're going to discuss an implementation of a queue, a basic queue using an array. So I created an interface called MyQueue, as you can see, and the interface, as you know, is the description, as the blueprint set of instructions for the methods that I'm going to implement later on in the class. So I call this MyQueue, and there are the four methods that we previously discussed on the queue lecture. So if you haven't watched the video called queues, this will be a good time to stop this one, go back to the queues video, watch it, and then come back so you will understand the implementation. So basically a queue has a method that is empty that will tell us whether or not the queue is empty. Enqueue, which is a method to add at the end of the queue. Dequeue is the method to delete the first item on the queue, and pick is a method that is going to return the value of the first element in our queue. There may be other methods that I'm going to have on my implementation, but those are not part of the interface. So let's move to the document that has the actual implementations of these four methods. I have created a class called MyArrayQueue, which is obviously uses an array to implement a queue. And notice here that I'm saying implements my interface, my queue we just discussed. There is the inclusion of this file, which is a non-such element exception that we're going to use in my code when we want to display or delete an element that doesn't exist. So you will see in the discussion. So basically, the array implementation is a very simple array. We have done this other times. I call these items, the items that I'm going to have on the queue. And again, I have my generic placeholder so that eventually this array could hold objects of any class. As in any other object, I'm going to have a constant, which is an integer value. And I'm going to start with a very short queue, a queue of 5 elements. And then I'm going to have 3 integer values that are going to help me to keep track of the following. First count, obviously. This is the numbers of elements that I have at any given time in the queue. And remember, I'm using an array, so it's important to keep track of the elements that you have. And then front and back are obviously the index that represents the beginning of the queue and the index that represents the end of the queue. As you remember, we're going to do insertions at the back and deletions at the front, so those two pieces of information are important. Also, keep in mind that this array that we call items is going to wrap around, is what is called a circular array. So not necessarily we're going to stop our operations when we reach the end of the array. We're going to just, if there are items available, we're going to use them the beginning elements of the array. So that way we are inserting or running the queue clockwise, so the indexes and the values of front and back will move then clockwise as we are inserting and deleting and queuing and dequeuing elements in our array. Then I have a constructor, and again I allocate memory for items, which is basically the array, and I call my method new, and I use my constant maxQ. So this, as expected, creates an array of 5 objects, and I'm doing a casting so that I can then insert objects of any type I want. Of course, at the very beginning, the queue is empty, so the front of the queue should be index 0, and the back of the queue is the maximum numbers of element minus 1. In this case, since max queue is 5, the back is 4. So at the very beginning, I'm saying my front is 0, my back is 4, but actually I do not have anything in the queue. So I'm going to use this count to determine whether or not the queue is empty, and then you're going to see that in the two methods that I have at the bottom. So at the beginning, queue is empty, so my count is 0. So it's empty obviously returns true or false, and all I have to do in this case is to use the value of count. So if the count is 0, that means that the queue is empty. This method should return true. Also, I have this other method which is Boolean too, and it's called isFull, and it's the opposite. So again, I'm going to use then my count to determine when the queue is full. Well, the queue is full when I have 5 elements. I'm going to use my constant again. So very simple. If count is 0, the queue is empty. If count reaches max queue, then the queue is full. Very important to realize that I'm not using front and back to decide the state of whether it's empty or full. I'm going to use front and back just to decide where to insert or where to delete elements to the queue. So let's talk about those two methods then. Okay, so we have the method enqueue. Remember, this is the method that adds a value to the queue. And remember again that we add at the end of the queue. So I need a parameter, which is the new object to be inserted. And the first thing is I have to make sure that the queue is not full. Okay, because if the queue is full, this is an array, so there's nothing I can do. I can't add more elements. So if this happens to be false, then I have to go to the else, and then I have to throw an exception that says the queue is full. There's nothing that I can do. Now, of course, you may say, well, can I increase the size of the array? Yes, I mean, you could then call a method instead of throwing the exception and double the size of the array, but I'm just going to show you in this code how it works. So I guess I have a very small queue of 5 elements. And again, when the queue is full, then I'm going to throw an exception indicating so. It's not full means that I have a space in my queue, a space in my array to add values to it. So I need to determine a new back, right? I'm adding a new value. The new value is going to be inserted at the end. I need to change the value of the index that represents the end. So I do this using this formula. And again, what this is allowing me to do is to wrap around the indexes. So it's like the end of the array is connected to the front of the array. It's like a donut shape. It's a circular array. And I'm going to be moving my indexes, in this case the index back, clockwise around that donut, around that array that is wrapping around. So I'm using this so I can wrap around, and I'm going to obtain basically the new value of the index called back. And that means the index where I should insert the object that is given to me to be in queue. And once I figure that out, well, I simply assign the new object to that location, and of course I need to increment the numbers of elements by 1. So it's a very simple insertion at the end. It's just that I need to know where the end is, because this is not a linear array. This is a circular array that wraps around and that moves clockwise. Similarly, the operation to delete is called dequeue, and remember, I don't need to know an index or a value. The only thing that I can delete is the object at the front of the queue. And again, I need to make sure that there is a queue so I can delete an element. So I need to check for is empty. So if it's empty happens to be true, right, then I will go to the else part, and that means, okay, the queue is empty, there is nothing for me to dequeue. So I'm going to use the same exception that I use in enqueue, but now I'm going to say, hey, the queue is empty, there is nothing to be deleted. But if the queue is not empty, that's what I'm testing for, that means that at least there is one value in my queue, and therefore I can dequeue that value. Okay, so what do? Well, first I make a local copy. I call this the front of the queue, and that's the item that is located at the current front of the queue. All right, why is that? Well, because I'm going to return the value that is being dequeued. So this is the current front right now, and that's what I need to return. In between, I need to reallocate the front because I am dequeuing. I am in the process of removing the item at the front of my queue, so I got a new front. So front is going to have a new value, and again, same comment that I made for the enqueue. Keep in mind that this is a circular array. The indexes wrap around. Once I hit the final index, then I go back to index 0, 1, 2, so on and so forth. I'm moving clockwise. So this formula will give me the value of the new front of my queue. And obviously, I need to reset count by subtracting 1 because I have dequeue an element. So it's very straightforward in terms of what we're doing for enqueue and dequeue, adding a value at the end or removing a value from the front. It's just that we need to be careful with these indexes back and front because it's a circular array. It's an array that wraps around. Then finally, I'm going to have two other methods. Let me start with pick, and that we discussed on the interface. And again, all this does is to retrieve the value at the front of the queue. So I ask again the question, is it empty? And if it's not empty, then I have at least one value in my queue. I can retrieve the front of the queue. So I simply need to say, okay, return the value located on my array items at location front. So it's very straightforward. But if the queue happens to be empty, so there is nothing to pick at, so I'm going to throw the same exception and I'm going to say, hey, my queue is empty. I added this method called the queue all for you to see how to do it. Sometimes we want to empty the entire queue. So how do we empty the entire queue? Well, simply by reinitializing the array. So I'm going to take my array called items that perhaps contains data, and then I'm going to reallocate it. I'm going to give him a new allocation in memory, and this deletes all the data that I have currently in items. And then I need to reset my values to the same thing that the constructor did. So front is the first index, 0. Back is the last index in my array, max queue -1, and my count is 0. Okay, very important to reset these values at the end. And these are the same values that we started with when we ran the constructor MyArrayQueue. That concludes the discussion of this implementation. I encourage you to watch a different video called My Link Queue, which is a linked list to implement the queue.